All right, thank you very much for the introduction, Stefan. So yes, this is a tutorial on sort of the integration of two lines of work that we've had within MDENet for a while. So on the one hand, we've had some work on the something called the education platform, which is essentially a way for people to be able to try out these model-driven engineering technologies in a bit easier way, rather than having to tell them, go and set up Eclipse and install these plugins and figure out all these things. We just drop them a link and they can just follow that, right? And the other line has been on creating a solution for doing continuous integration of model management programs, so that you can do the same thing that you typically do in code, where whenever you push a new version, you run your you run those programs, run your tests, make sure everything works, and so on and so on, right? So hence why we have this overall title of managing your models as part of a DevOps pipeline, because this whole idea of build automation and so on is very, very common in the DevOps culture. So let me just get started. I'll do first a bit of a general introduction, just to be sure that everybody is on the same page with regards to terms like continuous integration, continuous delivery, and all these different bits and bobs. And then we'll move on to the more technical side of the talk, where I go through these specific approaches that we have developed within MDENet. So first of all, if you want to follow from home, I already dropped some lines over in Teams to these same materials. But if you want to access the slides, they're available from that link in case you want to open it from your laptop or later. And also there's a GitHub Classroom assignment that will provide you with your own private repository to try out these things from home as well. And these links I can provide later as well. These are not in the online slides, just in case I didn't want to have random people from the internet unrelated to this symposium just dropping by into the classroom. Okay. But yeah, if anybody wants a little bit of time to just enter this classroom link, let me know. I can wait for a little bit for people to load that up, and then we can move on. I'll just leave a little bit of time. Yep. Yep. Okay. Actually, I think I can make it bigger. Is that better? So, yeah, 0IOEQ6CU. So if you follow that link and you are logged into GitHub, it will tell you if you want to join this assignment. If you accept this assignment, it will create a private repository for you in a GitHub organization, which has been set up to work with the education platform, right? So if I go and follow this myself, so I was kind of playing around, and it looks a bit different for me because I already accepted. But in your case, it would just say, do you want to accept this assignment? And if you accept that, then it will ask for confirmation. And then it will take a little bit. After a little bit of time, it will set up this new repository for you. So if I just reload the page now, in a moment, it will say that it created my assignment repository. And then if I follow that link, you will see that this is, I have my repository here. And depending on how quick you were at clicking on the link, you might either see this bit, which it says automated update of private repo link. That is because we actually have an automated workflow. When you fork this repository, it will make some small customizations in the README to help you run through this example. It's a little bit of customization in the README that needs to happen. Or you might see a little yellow circle around here, which means that that workflow is running at the moment and you have to wait a bit. Okay, but after some time, you should have these. And in the README, there's a whole bunch of links that you can follow to learn about all these different bits that are in this sample repository. Okay, I will go a little bit through what is in this repository in a moment. Okay, just wanted to make sure if people are properly set up. Is anybody still getting themselves set up or wants me to kind of go back to the link? just in case? Or is everybody okay? Okay, everybody's good? Okay. So I'll just go and move on to the next thing, and this is where having a microphone stand would be useful. Right, so let me first go through the basic terminology, first of all. So what is continuous integration, right? And this is a pretty old terminology by now, but just to be sure. So essentially, everybody knows that integrating the work of multiple developers can be very painful if the code bases have drifted apart, and it's been a long time since they last put together their work. So the basic idea of continuous integration is you do this as often as possible. So at least once a day, but ideally, basically as frequently as you can. And the idea is also that whatever you develop, you upload to a shared location, and whatever you upload gets put through a number of automated checks to make sure that if there's any problem, you detect that as soon as possible, because then it's easier to fix whatever you found, right? That's the basic idea of continuous integration. Then in terms of continuous integration platforms, you'll find some kind of integrated CI in pretty much any popular Git repository hosting platform. So GitHub has GitHub Actions, and the idea is you write a little YAML file that says you want to run these particular actions when a given event happens in your repository, and those actions are contributed by GitHub and the user community. So GitHub gives you some basic ones for checking out your Git code and uploading artifacts and so on. But then say the Gradle community gives you one for running Gradle, and the Maven community gives you one for running Maven, and so on and so on, right? Everybody kind of contributes actions that make their tools a little bit easier to integrate into these continuous integration pipelines. GitLab also includes its own YAML syntax, and they follow a different philosophy. Instead of people having to contribute actions, they say, no, we're just going to make our YAML syntax all encompassing. It will have all the information you need, all the details that you need to put in there, and that's it. We're not going to let people just contribute things because we don't know. We don't generally trust people to not mix things up. It's a slightly different philosophy that they have. And of course, there's also standalone CI solutions like Jenkins, but in this particular case, we don't have time to discuss Jenkins in particular. We're mostly going to focus around GitHub, and if time allows and you're interested, we can also talk a bit about GitLab, okay? And going beyond continuous integration, we have continuous delivery. And the basic idea is if you gain enough confidence about your CI process, then you can also make it produce new releases of your software, right? And that means that instead of, say, having to go through a very lengthy validation process until you put a new release, which means that maybe you do a new release every year, because it's automated, most of it, right? And you're very confident in all your automated tests and checks and everything, you can release much more often. You can release once a month. You can release once a day if you even want it, right? And even beyond that, if you're even more confident about your process, you could do continuous deployment, right? So whenever you push something to the main branch and it passes all the checks, you just go and put it into production, right? That's as quick as you can make the feedback loop, essentially, right? That's the ideal. Of course, it means you need to have a lot more confidence in your automation. Now, where does DevOps fit in all of this? Now, DevOps is more of a culture shift where the development and the operations teams, which used to be working completely separate from each other, and development would now and then just throw a new release over the wall, and then operations will somehow try to deploy it, and they might find some issue and say, actually, there's a problem in this thing. Go back to the drawing board, fix that, and let me know when you fix that. Instead, the culture of DevOps is they work together all the time. The development team is aware of the operational pressures, and the operations people are aware of the development pressures, and they work together to make sure that deployment is as painless as possible, and also that the software is using that infrastructure as best as possible. And now, usually this implies following practices such as continuous integration, continuous delivery, continuous deployment, also automating your infrastructure, and introducing all these automated pipelines that cover building the products, provisioning any service, and so on, right? And then if you're doing that, if you're following DevOps, then the question is, what happens if... Hello? Oh, anyway. So if you're using models, then you want to treat them the same way that you treat code, right? You want to put them through the same bits of automation, where if a new version is pushed, you want to put them through the various transformations and tests and checks. And you want to distribute them in the same way that you distribute code, right? You want to upload artifacts to certain locations and share them with different people. And in fact, and that's something that we also show a little bit, you may also use continuous integration information as a model, right? As part of a model-driven engineering pipeline as well. So we'll cover this bit, like how do you use models for CI in the same way that you would do it for code. And we'll discuss a particular solution for doing this. So let's go to a specific case that we've created for this presentation. So this one is if we want to go from a set of models to a Gradle project that then we could package up and we could deploy to an artifact repository and so on. And we want to do all these from your usual continuous integration pipelines. Okay. So for this tutorial, Candy, you already went through those links, but in this case, we have links here as well, and these ones you can see from the online slides. So as an example, we've created a model-driven pipeline, and there's a link here that if I follow into a new tab, it takes you to the GitHub repository that you have now your own copy of. And this one has a number of scripts written in the Epsilon set of languages that essentially turn a model of a state machine into an implementation in Java, plus its tests as well. And it also puts them through the tests, right? So by the end, you have a tested implementation of a state machine with specific examples. And it has the whole pipeline, right? It does model validation, it transforms that model into a Java model, and it turns the Java model into a Gradle project, and it runs the Gradle build, including the tests as well. So let's go over it. And for this, we'll use the MDENet education platform, just so we don't have to go and set this whole thing up in Eclipse. So if I just follow this link. Now, I'll follow this link from this slide, but if you have your own classroom repository, you'll see if you go down to the README, where it kind of explains the structure of this example as well. And if you keep going down, you'll see that it has different ways to run this example. So it has a way to run it from Eclipse, it has a way to run it from Docker, and it has a way to run it from the MDENet education platform. So if you want to try this first bit, where we're not going to be changing the transformation yet, you can go here from the section that's titled from public template, and you can just follow this link. Okay, if you follow this link on a new tab, and it's the same link that you see here on this slide where it says MDENet education platform, you'll see this page, which is the education platform running this specific example. And the way this works essentially is, I'm not sure, it's probably a bit hard to see the address bar from the back. Can the people at the back see the address bar? It's a bit, maybe it's a bit hard to see. Yeah, but just so you know, the basic idea is you have education platform ndnetwork.org, and then through the URL, you provide the URL to a JSON file that specifies how to configure this interface. Okay, so this JSON file says you've got these 4 activities here, and these 4 activities here are for different things, right? So there is one which is for validating the state machine, which is because it's the first one, it's also the first one that you see. And in this case, I'm just going to make the font a bit bigger. Okay, is it readable from the back if I zoom in enough? Okay. So this example, what it does is I have this model of a state machine, which is a very simple finite state machine that just reads characters and either accepts or rejects a string, essentially. And this is one that can accept strings such as just an A or ABA or ABZ, BA. So A plus a number of characters between B and Z, and then A at the end. It will accept those and it will reject anything else. Okay, so I have these initial state, first A, and I have another state called B, and I have another state called last A, and I have transitions between states. So I start at first A, and then if I have an A, I will move to B. When I'm in B, I will stay in B if I read anything, any character between B and Z. And then if I'm in B, I will move to last A if I read an A. Okay, so it's just a usual state machine that reads characters one at a time. And as I say, we have both the transitions and the test cases, right? We know we have specific examples of strings that it will accept and strings that will reject. Now, if you want to run this validation program from the platform, you can just click on this little play icon that you have here on the EVL pane, and that will run the program. And in this case, the way that this EVL script runs in the education platform, it will essentially highlight any violations of these constraints. So at the moment, we don't have any such violations. We could try and just remove some of these bits and see if it tells us that we have a problem. So if I delete the initial state from here, for instance, and I run that again, you'll see, if I zoom into this, that now it has highlighted in the state machine that it's not meeting that particular constraint, right? So this is a way in which you could get employees who are learning about MDE or students who are in an MDE course to just quickly try out these ideas without having to go through all the trouble of setting up Eclipse and so on, right? The nice thing again about this is the way this is structured is through just configuring a JSON file, and the actual code that runs these model management programs is actually a microservice, which will just take a certain JSON message, run the program, return a certain JSON output, and that's it. So if you want to integrate a different language, which is not the Epsilon languages, it's a matter of configuration, really, right? A certain conventions that you have to follow, which are documented in the education platform repository, and you could integrate different languages. And as far as I'm aware, people have tried this with OCL as well. I know Arthur is trying that with his language YAMTL as well, right? It's a matter of configuration, really, if you want to try and integrate other languages. There's a few other niceties as well. So you can, if you want to get a diagram of, say, your model, you can click on this little diagram icon, and that will use another microservice that we also have in the platform, which will take this model in this flexMI notation and this meta model in this emphatic notation, and it will draw a diagram out of this, which is very similar to this one, except it doesn't do the validation. And we can also generate diagrams from the meta model as well. So this gives you a little diagram of the meta model. And I could zoom in a little bit if you want to make it a bit easier to read. So as you see, we have a state machine that has name, initial state, states, transitions, and test cases. And then it contains the states, it contains the transitions, and it contains test cases, which come in two kinds, accepts and rejects test cases, right? So this is the validation stage of the pipeline. Now, the way that this repository has been structured, or this activity has been structured, is to allow you to play with each of the separate steps of the pipeline separately, just so you kind of get to play around with the different languages. But in CI, they run one after the other automatically. And I'll kind of switch to that in a bit. But I just wanted to walk you through the different stages. The next stage after this automated validation is the transformation of this state machine model into a model of a Java program. So now that you see that the target meta model goes now into a bit more, it gets a bit more complicated. Now I have two meta models. I have a source one and a target one. So I'm turning models that conform to this meta model into models that conform to this other meta model, this Java-inspired meta model, where I have Java files, and the Java files have imports and Java classes, and the Java classes have They have methods and visibilities and all these things, right? So this is essentially a full-on Java abstract syntax tree. Heavily simplified and not trying to cover the entirety of the Java grammar here, just the bits that we need for this particular case, right? But the basic idea is the same, right? I have this ETL program that takes the state machine model and transforms that into a Java model. And it's in ETL, follows the usual syntax, which essentially it's rule-based. And the rules are essentially turn this thing into this thing with some additional code in there in the middle to set properties, associations, and all these different bits and bobs that we did. Okay, I won't go too much into the detail because again, it's not a tutorial about ETL, but just so you know that this is what's going on. And if I run this transformation, you'll see that this one takes a bit longer, and it's mostly because it's actually really just the diagram rendering and kind of layouting. But this one, it's a bit more complex, the output of that, right? Because this gives you the actual model that got produced, right? And you get the full, essentially, abstract syntax tree of this. So you see I have a Java file, which is the test class, actually, based on JUnit, with its methods and its references between methods and annotations and everything. And I can also go here as well. And you see I have another Java file, which is the main class that actually implements this state machine. Okay. Now, this bit obviously is just an abstract syntax tree. We need to turn that into actual code. And for that, we have, and by the way, you can still do the whole visualization of the meta model. If you try to visualize the meta model of Java, it's not as nice to look at because it's a bit more complicated. Now you have this whole tree hierarchy of expressions that you can have in a Java program, or the different parts of a Java program, and so on. It gets a bit more complicated. But then once you have this particular Java AST model, you can go into a model-to-text transformation that will take the Java model and it will produce some Java code. So for the activity, I kept it very simple. So the input model, to kind of just show people that this works, is extremely simple. The actual thing is a lot more complicated when we're running in CI, right? This is just so people know how this essentially works. The way this works is we have an EGX program that says how to turn this model into different files. And the way it does this is basically says turn every Java file into a file according to this, where the path follow is computed from this expression. So it goes into the Gradle lib source directory. If it's a test class, it goes into the test folder. If it's a normal class, it goes into the main folder. And it's Java code, and it follows certain conventions based on packages and so on. Please generate that code according to this particular template. So again, it's using this EGL template, which is the one responsible for actually producing the Java source code out of this model. So if I click on this play button here, I will get the code. Again, this is extremely simple example model here, just to show you how this works. And this produces two files. It produces a normal class. So this is the normal class. And then it, for instance, it will produce a test class, which will be this one. Okay. And as usual, you still have the same capabilities to visualize your models in the same way with the same microservice and so on. And so these are the three main stages of this particular pipeline. Another question is, okay, suppose that we have developed these three stages and we actually want to run them in CI, right? Now we want every time you commit a new version of the program, I want to rerun these and run the build and run everything together. How do I do that? Okay, so I'll just go back to the slides and let's keep talking a little bit about this. So, as I said before, one issue that we have for continuous integration around models is there isn't really that much of a unified interface for manipulating models from a GitHub Actions workflow or GitLab as well. And actually many many bits in modeling, in particular in the Eclipse modeling framework based ecosystem. Lots of them, they actually need a full-on Eclipse installation, which is rather difficult to set up and so on. And some of the operations, even though they don't really need interaction, they expect to be run in an environment that has a screen, right? Unlike a typical CI process, which runs in a headless mode. So what we've done is we've created a Docker image for doing CI with Epsilon, and that is available on GitLab. So if I go here, this is the GitLab project that hosts the Docker image. And I can kind of go a little bit into how this Docker image is done internally in a bit, because probably, if you want to do it yourself, you might want to tweak a little bit what goes into that image in the first place. And that also has, so that image essentially has an Eclipse installation that has Epsilon pre-installed into it. And if you wanted, you could add more features. You could add more things into that image as well if you happen to need additional software to run your CI processes. The image is directly usable from GitLab. And essentially, the way you do that is you use the GitLab CI YAML syntax. And I can show an example here because we actually run it as part of testing the image. So in GitLab, the CI processes, they're written in these special .gitlab-ci YAML files. And the way you do that is you go into the YAML file, and a GitLab CI YAML file is structured into stages. And in each stage, you'll have a number of different jobs that you run as part of that stage. And we have a test stage where we try and run this image against some example workflows that we have. So if I go down to the testing part, we essentially have these two-part definition where we first describe the general structure of a CI job in GitLab. And we say, well, an execution, a build execution, belongs to the test stage, and it uses that image, right? So it's in the same repository. So in this case, we just provide we just use this variable that says the image that comes from this project. We use the latest version of that. We disable the endpoint, the entry point, because it's not useful for GitLab scenarios specifically. And then in this case, we just say, just use the entry point and run it against this workflow. And I'll explain a bit how these workflows are run, and run this particular target in the workflow. And that will run everything, right? So this is as simple as it gets. You just basically point your Docker image to a Ant build file with a given target, and it will run those Ant tasks, right? This obviously does depend on you having provided Ant tasks for your modeling tools, but most of them in practice do. Epsilon, for instance, has Ant tasks for all the different things that you may want to do around models. And another thing that's interesting about that CI Docker image is how the Eclipse installation is defined. So if you are somewhat familiar with Eclipse, you might have in the past built your own products in Eclipse. It does not use products because products are quite annoying to define in practice when you're trying to do them. So it actually doesn't use that. What it uses instead, if you've ever downloaded Eclipse from the website and you try to install it yourself, you may have tried something called the Eclipse installer. And the Eclipse installer is just essentially like a wizard that you follow step by step. And you say, I want this version of Eclipse. I want it with these things and so on. Please set it up for me. That's exactly what we use. We use that, but in a headless mode, essentially. Right? So if we go to the Docker file that we have here, where we build this image. Whoops, I went a bit too way back. If I go to the Docker file, what you'll see, there's all these bits, details around Eclipse. So for instance, we install some bits that you may need in a full Eclipse, like this xvfb package, which provides us with essentially a fake screen for those things that say that they want a screen, even though that they shouldn't. We do it this way. So we have a number of, we take care of a number of different annoying details about getting this right. but also we essentially download the Eclipse installer from the official website, and then we set it up with some repositories for Eclipse features, things you may want to install into your Eclipse. And then we take a list of what is called installable units, but these are actually just Eclipse features, right? These are groups of Eclipse plugins. So if you've done any kind of release engineering for Eclipse, if you've done anything like creating, update sites, you'll be familiar with the concept of a feature. So what essentially you need to do in order to install your specific software into this Docker image, you just add it to this particular list, and that will build you a Docker image, which you can then use for CI, essentially, right? Because then at the end, what we do is we just run the Eclipse installer with these different options, and that gives us a nice installation that we can package up into a Docker image and upload to this project. Because that's one thing that it's the same in GitHub. It's very similar. In GitHub, you have the GitHub container registry. So you can also have your own private images in GitHub. And it's the same in GitLab. In fact, GitLab was the first to do it before GitHub. But anyway, it's a moot point. So the actual image is available from the container registry of this project. So this Epsilon CI container image is the one that we'll be using for CI in this particular project. Okay. And if you go here to the details, if you copy the image path, that will give you the full path to the image in case you wanted to use it from anywhere, right? So I'll just copy it somewhere so you could see the path, right? The full path to the image would be essentially that, right? That's the path that we would normally use if we wanted to use this from, say, GitLab. But from GitHub, we have something a little bit easier to use, which I'll go in a bit through, in particular, this GitHub action. So in the case of GitHub, we have created our own GitHub action. So as I said before, you can contribute your own. If you have a particular mechanism that you run a lot and you want to kind of make it easier for people to use, you turn it into an action. You can put it up on the marketplace, and it becomes a lot easier for everyone else to do it. So I can go into this GitHub action section, and this is the repository that defines the action. And the way you would use this action in your workflow would be with something like this. You would just say, use this action with this build file, run this thing, that's it. And that takes care of all the details of this particular Docker image and this particular way, and run it with these particular arguments and so on. Okay. And it really simplifies things, but you have to go through this extra little bit of detail. The actual way that this works is it's just a GitHub project that has its own little YAML file that explains how this action is defined. And this particular one just says, this is a Docker action that is run with this image and using these particular arguments, right? So the definition of one of these is really simple, but it's one less bit of complication that people have to go through, essentially. Okay, right. And final thing I wanted to show you is for this slide I wanted to show you how we went and added to the image some recent work we did in the Epsilon project, where we added support for YAML files and JSON files as models. And we just had a pull request about it. And just to show you how simple it was, we just essentially went to here and we just added these 4 lines. That was it, right? We added these 4 lines that then triggered the build process of the image. We then did a release that put up the new image on GitLab, and everybody who uses the GitHub action will just use this version that also has the YAML and JSON drivers, right? So going back to the slides. Now, in order for this image to work, as I said before, you need to have something called an and build file. And because essentially, in terms of workflow tools that are actually supported by model-driven engineering technologies, as far as we know, and is the best one. We don't see that many Maven plugins or Gradle plugins for these things. It's mostly just and. So we still went with and. And one good thing about using this Docker image that has an Eclipse installation in it, it's you can use exactly the same and file that you would use from Eclipse, right? If you were not using an Eclipse installation, you will have to go through a lot more gymnastics to get the AND file to actually run. You have to get it to download the libraries for Epsilon and set them up and deal with dependencies. You don't need to deal with that, right? You're basically the same AND file that you'll be working on from your local Eclipse, you can use in the same CI process. So I'm just going to go through that and build file that you have in your own repository. And if I go to, whoops, I'll just zoom out a bit and I go into the build file, it will be the same as you would have normally in Eclipse. So in this case, we have a build file. I'll just make it a bit bigger so it's a bit easier to read. And what the build file is like, it has a root project element, and then inside I have a number of target elements with different names. And in those, I just specify what I want to do, right? So I say, for instance, that for the validation stage of the process, I want to load the state machine model. And you'll see that that's not a standard AND task, and I will just go through that in a moment. But then after that, I just use the Epsilon EVL AND task to say, I want to run that EVL script against that model, give me the results, and then I'll just dispose or unload the models, right? For my transformation stage, I do the same thing. Please load these two models. I want to load the mini Java model in a way that I want to save it by the end of the task when I dispose of the model. And then I run my ETL script, passing these models, throw them, and then dispose of the models. So unload, and in the case of the mini Java model, actually save it. For the generation stage, we do exactly the same thing, right? But instead of that, we run this EGX script and so on and so on. The one little bit of AND magic that we have here, just to make things nicer to read, is we use something called a macro def. Whoops. We use something called a macro def in AND, where you can, this one I will go later through that. That's for a different part of the presentation. But in this one, you have this idea of a macro def, which allows you to essentially define your own AND task, essentially, in the same AND file. So you can just say, when you use load state machine, you're actually just running these bits. It's kind of like a template-based AND task, if you think about it, right? So when I say load state machine, I actually mean this, right? And when I say load mini Java with support for these two options, then what I'm actually doing is this. It's just a macro, really, right? I'm just defining a macro here. So if you define an AND file like this, then you can automate the build, the manipulation of your models in GitHub Actions or GitLab just fine. So I'll just go back through this. And the final thing, right? So we have the Docker image, we have the workflow, but now how do we actually run this thing on GitHub? That's when we want to write the GitHub Actions workflow file. So in this particular case, what we have here is, oops, I'll just go and let me just go back through, not this repository, this local one that you have here. we also have this bit where we upload intermediate results. So we can kind of see how it evolves over the workflow and say, okay, this is the stage in which it's going wrong, right? Which is how we kind of nail down and said it's actually the ETL, which is having a race condition here. Okay, I think it's working now. Yep, okay. Right. Yeah, if there was another question. Okay. Right, so going back to the workflows bit. So the last part as I was saying is to put this together so you have a question? No? Okay. So the last bit to put this together is a workflow. Particularly, we want to use the one that we're talking about now is this build workflow. Again, this is a syntax which is defined by GitHub, right? And the way it works is we provide a name to every workflow, and we say on which events we want to run this workflow. So here we're saying we want to run it for pushes to the main branch and also for pull requests, right? We want, if somebody sends a pull request, we want to go and test the model essentially. Then we specify on which kind of machine we want to run this. So the default that GitHub will give you is an Ubuntu machine, an Ubuntu Linux machine. And then we have the steps. So we first have, and this is where you see that there's a mix of steps or actions that come from GitHub and some that come from us, right? So we have one from GitHub where we check out the code. And then you'll see that we have a number of different stages. So we could have just had one step in which we run the full ANT workflow. Essentially, we run every target. But the issue with that approach is if something fails, then we don't get as nice reports as we would get if we kind of separate each stage on its own step of the workflow. So we have a step where we use that GitHub action I just talked about. We use it to run the validation, the EVL script. So as you can see here, I don't even need to specify the name of the build XML file because I'm just following the convention of build XML. So I don't even need to provide that. I just say, I just want to run the validate stage of that ANT file, right? From inside an Eclipse, actually. Then I want to run the transformation, same thing. But we also do this bit in the middle where we upload intermediate results, right? And as I was saying before, this can be important because you may have problems, you may have errors, right? Even if the script completes, it could produce a model which doesn't make sense, and then something else fails down the line. And you want to be able to kind of see exactly where it went wrong. So this is why we do this bit where we upload artifacts in the middle of the build, right? Then we generate code, right? We do the same thing. And we also upload the code to the build as well. And then we use a standard Gradle action to just try and compile and run the tests for that generated code, right? So we're doing CI not only over the models, but also over the generated code as well, right? So by the end, we know that our models are valid Java code, that they compile correctly, and that they pass the tests, right? It goes beyond just the models. And if you have this, every time you push, you get a little extra bit here in your Actions tab for the repository, where you'll see the different workflows that we have. So I'm just going to kind of be able to see everything again. I'll just focus on the executions of this CI, this specific CI workflow, and I'll zoom in again. Right, and you see that this runs for every time I push something, right? This is running here with all the different information and so on. You probably see from before, you see some failing ones here as well, right? So this is where I was kind of tweaking some bits and dealing with some of the that race condition I was talking about before. And I'll just go back to the most recent one. And as I was saying before, the nice thing about doing these uploads in the middle is I can actually go to these artifacts here and I can just download this, right? So if at some point this is failing, I could just pick at the model which is getting generated here in the middle of the process, and I can just look at the model and see if something is going wrong, right? or I could go to the generated code here, and that would get me the source code. And I could have a look at the test code that this generates, right? I could have a look. So when I had, oh, this has frozen again. I think this has frozen again. Yep, because at the moment I'm showing the code for the test class. I'm moving my own mouse and it's not moving in the same way. Yeah, that's your mouse, yeah. Well, while we wait for that to get fixed, any other questions? Okay, let's just wait for a bit. I'll stop sharing, start sharing just in case. Okay, so I stopped sharing and that worked. I start sharing and that, okay. Right, so if I just go back to the code. So I'm able to look at the code and see if the code looks fine and so on, right? So for instance, when I was having that race condition, I was getting here some odd looking code that had 2 test annotations and multiple copies of the behavior and things like this, right? But I could debug that straight from just downloading the artifacts of the build, okay? And as I said before, I can do the same for the implementation of I'll just close this file. I can do the same for the implementation of the state machine. So if I go back, and then I go into here, I can do the same thing here, right? I can see the implementation of the state machine as well. Okay. So that's the workflow. So now if you want to try and trigger the workflow yourself, we can try to use the MDENet education platform for this. So the way this works is if you go to the repository that was generated when you follow that assignment link, I'll just find my own one when I accepted this. Let me just go to my own one. All right, hold on a second. Okay, so this is the one that I have. Now, as part of the creation of the repository, there will be a workflow that has run, which will have customized the README for you a little bit, and it will have fixed essentially for your repository these 2 links, right? This one where it says from GitHub Classroom assignment. If you follow this particular link, okay, that one, if you have that open on the machine on your machine, you may notice that the URL is a bit different. It's pointing to your own private fork, and it has an extra repository saying this is a private repository. Please authenticate to GitHub before you actually open this thing. So if I follow this link and everything works fine, which it should, it will show, and this is something back from into the education platform, it will show this sign-in page where I can click on sign in with GitHub, and this will talk to a little server that we have, which will, if this is the first time that you're using this platform, it will actually show you a permissions page where GitHub will say, do you want to give permission to this particular app to modify your repository? And you'll say yes, and it will take you back to this. Now you see that we've opened the activity, but this is actually running off our private repository, right? So now it's signed into GitHub using your account, okay? And obviously, one thing that you need to do in order for this to work is you need to have the GitHub app that we have created for the MDENet education platform. It has to be installed into your repository, right? And you get to control where you install it. Okay, so in this particular case, it just works because we have installed the GitHub application into the organization that hosts all the repositories for this classroom assignment. So it works out of the box. So if you were a teacher and you were using this education platform, you will create an organization for your students, right? You would install the application into that, and then you will create a classroom assignment within that organization. And then students don't have to worry about installing this app or doing anything, okay? But if this is just your own personal account, then what you could do is you could just install the application, the GitHub application, only for that one repository, right? In case you're worried that, it will gain access to all your repositories and there may be a bug and you may be losing important work or something like that, okay? Now, the one thing that is enabled when you do this whole thing about signing into GitHub is now you get this save button, right? And what the save button does, it allows you to essentially just change anything here. And once you're happy, you click on save, and that will commit the contents of the panels in this screen. It will commit them back to your GitHub repository, and that will trigger any continuous integration pipelines that you may have, right? So if I were to change, for instance, let's say that so I have this constraint saying that the name of state has to be a valid Java class name. So I'm just going to change the name and put something that is not a valid name, right? I'm just going to put like a minus there. Oops, I shouldn't have pressed Ctrl S. I should have clicked on save. And if I click on save, it will take a little bit, and then it will say that the activity panel contents have been saved. And if I go back to my repository, I will reload the page, and you can try this yourself as well. And if I reload the page, you see I now have this little yellow circle here. That means that a CI process is running. There's a workflow which is running. I can go to the Actions tab of the project, and you'll see that it's running this, right? Now, that's a little quirk of the platform at the moment, that it will do one commit for every panel that is editable in there. Yeah, that's something to think about to improve later. But basically, you see that it's running for all of these, and it should be failing the validation stage, right, at some point. So if we go into the build, you'll see that now it's going through the validation process, and it failed, right? It failed the validation because it didn't pass the validation, right? You see here that it had 2 errors and 0 warnings found during validation, and okay, and if I go to this bit, it will say, it mentions the validation problems, right? So the state name should be made up only of alphanumeric characters, and every transition needs a to state as well, right? So there's one transition there that I didn't update, and now it didn't have a to state, right? There was no state with the same name, okay? So that means this failed, and I did my CI process. You see that it failed as you should have, right? So now I'm just going to fix my model, save again. I wait a bit more. Okay, I think maybe it's just that it reused the same bubble. Let me just go. Okay, so I have the commits here. All right, so if I reload the page, just to check, and if I look at the commits that I have, so it should have been not this one, this one. Okay. Right. That's interesting. Right, okay. Let me try this save again. So this is the demo effect. Think. All right. There seems to be some issue with the save. Let me see. Okay. So that's interesting. Okay. I am getting some kind of error message from this. That's interesting. Let's just reload the page just in case. Let me just save here. Okay. Probably something to look at together with Will and Stefan to this. Whoops. Okay, now it's saved as it should have. There's this one commit, which it will have changed the model back to its original state. And now we should be seeing that CI process pass in a bit. So we just wait for a bit here. Right. As I say, the main thing that's nice about using these different steps is you can just follow the process as it trickles through the different stages. So you see that it has this bit where it runs, it has this part where it validates the model. You can see all the different stages, right? Transforming it, uploading it, generating the Java code, and so on. And you can also see how much time was spent in each different step as well, in case you're kind of wondering, which bit is taking up the most time in your pipeline as well, right? So you see they uploaded the model, it's now generated the Java code, and it has uploaded the Gradle project artifact. Now it's running the Gradle build. And once everything's done, let's just let this run until the end. We'll get the final result. And there we go. We're almost done. There we go. Right. So there you go. That's the whole CI pipeline having run for us, right? For this out of GitHub Actions. It's happening on every push, and that way, whenever. Now, one thing we haven't done in this workflow, we haven't gone all the way to say actually upload this artifact to, say, the GitHub package registry, but we could have gone that extra mile and actually uploaded these to the package registry, and then other projects could be reusing this as well and so on. Okay. Are we done with time? I think we still have 20 minutes, sort of. Okay, right. So that was the main bit of this, but then I wanted to show another possible use of model-driven engineering technologies, which is using the CI, the continuous integration pipeline information itself as a model, right? And this is just to show that in the Epsilon project we take a pretty flexible view to what is a model, what is not. We basically think anything that is reasonably structured and so on, and that can conform to some types, is essentially a model. So a YAML, a JSON file, is a model. It's just that the meta model is sort of implicit in its structure, really. So since version 2.5.0, Epsilon has drivers to read and write JSON and YAML files, and in fact, the JSON driver can read directly from HTTP with custom headers and everything, right? So you can just talk to the GitHub API directly. And here we have an example in this repository where we essentially just talk to GitHub and we get the response from GitHub and we turn it into release notes, right? And it's just an EGL script. It's the same model-driven engineering technology, but it's being used on responses from your CI system, actually. So that has its own activity in here as well. So if I go into here and I go into these generate release notes example, you'll see that this is an EGL script in the same style as we would use for any arbitrary model. And here, just in order to be able to quickly play around with this, I just saved a response that we got from GitHub. But in the CI pipeline, it actually calls GitHub in the CI pipeline, right? Not in this example, because I just want the people to be able to play around with this without, running into the rate limit of GitHub, essentially. So if I run the program, I run this EGL program here, and I get a nice list of, release notes just saying these are the bugs that got fixed, these are the announcements that were done, and this is the workaround, and you have the title, and you have the link, the number of the issue, the link to the issue, and so on, right? And the good thing is, this could be part of your CI pipeline. You could also do things like taking that JSON file and combining it with some other, EMF model you may have lying around, or a spreadsheet or something, and do something useful with it, right? You don't have to just stick to EMF models like we usually do. So if I go back to the repository, and I just show you through the other workflows, there's another workflow here, which is the Epsilon report workflow. So this one, I have it set up a little bit differently, just to show you the variety of events that you can use to trigger builds. So this particular one, it runs on a schedule. So it runs at 5 a.m. on Mondays, just a random time, just not to hammer any servers or anything like that. And you can also run it manually. That's what the workflow dispatch means. You can run it manually yourself. And what it does, it uses the same Docker image that we just saw before, and it uploads an artifact, which is these release notes, right, that we produce. And the nice bit about this, as I said before, if I go back to the ant build file, and I go to the ant task, what you'll see here is it's actually the JSON model is just talking to the GitHub API, right? It's just directly talking to this HTTP address, providing these additional headers, loading the model, and putting it through an EGL script, which then produces some release notes that I can upload to the build, and I could use as part of my, release engineering strategy if I wanted, right? And if I go to the if I go to the actions, and I go to this weekly Epsilon 250 report. Ooh, okay. Oh, I haven't run this one manually. Okay, this is running now. All right, I haven't run it on this particular fork. Yeah, because as I said before, it runs on a schedule. So this one I'm just running manually because it has this workflow dispatch. But if I went to the main repository, we should see a previous execution of this workflow. So here we go. So see, this one I run manually myself, and this one ran automatically on a schedule. And when I go here, I have my release notes. I can download that, and I get the one from a few days ago, I would assume. So from yesterday, basically. And this is the one from yesterday. Okay, and this is just entirely automatic, but it's using the same Epsilon languages that we use for manipulating models, right? So, not much more to go through. As I said, these are the alternative triggers as well, and so on. But as I said before, this is just one example of what you can do. The good thing about this is Epsilon supports many different kinds of models. It doesn't have to be just EMF. We support JSON, YAML, Excel spreadsheets, XML files. We have a very long list of different kinds of models that we support, actually. And as a conclusion, we just went through how to use this Docker image to do CI on models and put them through a certain sequence of stages and so on. If we want to play around with the different stages, you don't even need Eclipse. You can just open these stages in the MDENet education platform and play around with them. And we have also shown how you can use CI information as a model too, and potentially combine it with whatever else you can think of that you deal with in a CI pipeline, essentially. And that is pretty much it.